So in this section, we are going to talk about the bias in the cohort study. So we know that the bias is a systematic deviation of results from the truth. And this is an error that may occur during the different periods in a cohort study. For example, during the recruitment of participants, during the data collection, analysis, reporting, or publications. They can lead to results or the conclusion that are systematic different to truth. And in cohort study, there are several types of the bias, including selection bias, information bias, and confounding. So let's look at the selection bias first. So selection bias usually indicate that the participants that were recruited in cohort study have some purpose. So this purpose means the selection of these participants may not be very well designed. So which means that the participants in our cohort study are not very well representative to the total populations. And the result of or the reason of the selection bias could be several types. For example, the selection bias could occur because of the non-participants. For example, in cohort study, we can send many invitations to thousands of participants, but not all of them will participate in the cohort study. So for those who did not participate in the cohort study might cause our selection bias in the cohort study, because we don't know those people who are not participated in the cohort if they have any significant difference in the association between exposure and the disease outcome. We don't know. So that's why the non-participants can cause some selection bias. And another very common selection bias is due to the loss of follow-up. We know that in the cohort study, we need to follow up them for long periods, for 5 years to 10 years, or even more than 10 years. So during this entire study populations, many participants, they can drop out the study, or they just lost of the contract. For example, they can just move out, or maybe they just don't will to be involved in this study anymore. So we don't know their disease stages. So this is called loss to follow-up. And they can cause follow-up bias because we are not sure if these people who are lost of follow-up have any differences in the disease outcome compared to those people who remained in the study. Another reason for the selection bias can be explained by this healthy worker effect. So these healthy worker effects usually happen when we try to recruit occupational cohorts. So for example, we can conduct a study in some health professional provider. So this particular occupational cohort or population, they might have different association between the exposure and the disease outcome, and then therefore they might not be able to be representative to the general populations. So this can also cause selection bias. And for information bias can be introduced when information obtained on both exposure or outcome are systematically incorrect. So either when exposure is measured differently in people with the outcome, or when the likelihood of detecting the outcome varies between exposed and unexposed group. So there are usually two types of information bias, and they could have different impacts on our association between exposure and the disease outcome. So the first type we usually call non-differential misclassification. So this type of the misclassification of exposure or outcome, usually they are not related to exposure stages, or they are not related to disease outcomes. So they are more like random errors. For example, we measure the height for the participants. So this measurement can have some minor measurement errors for everyone, no matter what exposure status, no matter what disease outcomes. So this is random errors. So these random errors, or these non-differential errors, will tend to make our result as a null value, which means we cannot detect any significant difference between the exposure and the disease outcome. Second type of the misclassification is called differential misclassifications. So this type of the information bias usually occurs when the errors is happen relative to the exposure stages or the disease outcome stages. So this will make our associations different from the truth. So which means this can cause a wrong association between the exposure and the disease outcome. And I would say this type of information bias will cause more severe problem than the non-differential misclassification. The third type of bias is called confounding bias, and this is one of the most important bias in the cohort study. So let's first look at what the confounding mean. The confounding is the bias of the estimate effect of an exposure on an outcome due to the presence of a common cause of the exposure and the outcome. Let's look at the example to understand this definition of confounding. For example, now we are going to observe the association between the coffee drinkers and the risk of the lung cancer. So in this case, the cigarette smoking could be the confounding, because usually people who drink coffee, they also smoking. So cigarette smoking is both related to more coffee drinking and also related to the lung cancer. So in this example, cigarette smoking is a confounding factor. In epidemiological study, a confounder is defined that this factor must be associated with both the exposure and the outcome. Moreover, the confounders should not be involved directly in the causal pathway between the exposure risk factor and the outcome. For example, in a study, we are going to evaluate the association between the smoking habits and the cardiovascular disease risk. So it seems that blood pressures can be the confounding or can be the confounder because blood pressure can both relate to smoking habits and also relate to the cardiovascular disease. So this blood pressure seems to satisfy the definition of the confounder, but we need to know that smoking can also increase blood pressures, which can then related to increased risk of the cardiovascular disease. So which means blood pressure is in the middle way of this pathway between smoking and the development of the cardiovascular disease. So usually in this case, we will not call blood pressure as the confounder. So in a study design, we can use some strategy to control the confounding bias. For example, during the study design phase, we can use matching. For example, we can matching for the age, for the gender, for the racial group. So we can reduce the confounding effects by these common risk factors. Or we can use some statistical techniques during the data analysis phase in order to reduce the effects of the confounding bias. For example, we can do the stratification. For example, we can divide our population into male and female. So we can eliminate the confounding effects of the gender.